There are going to be three main types of questions on this quiz. What we learned in sections 2.6, 2.7, 2.8. All graphing, but three different types of graphing. The first type in section 2.6, we talked about graphing inequalities. So when it's not an equation, but it just has the greater than or less than. The first thing we do is graph the line as if it's an equation. So what kind of a line would y equals 2 be? Horizontal at a height of 2. We're going to use a solid line because there is an equal to bar. So that means it can actually attain that line. Or it could be y is greater than that line. So how do I show that? Shade above. The next one is in slope-intercept form. So the first thing we want to do is graph the line. What is its intercept? Negative 1, and that goes on the x-axis, or sorry, the y-axis. That's a y-intercept. Graphed it in the right place, said the wrong thing. And then a slope of what? 3 over 1. So from that point up 3 over 1, as many times as you want. You can go backwards as well to get a lot of points, because this one needs to be a dotted line. So it's often hard to draw dotted lines very straight. The more points you have, a lot of times that helps. We want a dotted line here because there's no equal to bar on it. So that means it can't actually be that line, it can just get really close to being the points on that line. And then we need to pick a point and say, where does this work? It's going to work on one side or the other. I like to test the point 0, 0 as long as your line doesn't go through it. If your line is going through 0, 0, you can't test that point. Otherwise, that's my favorite to test, but you could test any point. Like if 0 is less than 0 minus 1, or 0 is less than negative 1. Is that true or false? That is false. 0 is not smaller than negative 1, which means that that point is not correct, which means that side is not correct, and the other side should be shaded. Questions? Okay, this one is not in slope-intercept form. It's kind of in standard form, but if we try to graph it using our cover-up method for standard form, it's going to give us that our x-intercept is 0 and our y-intercept is 0, which is just 1 point, and we can't make a line out of that. So what we need to do is get y alone on this thing. So how do I get y alone? Subtract x from both sides. So negative 3y is greater than or equal to negative x. And then divide by negative 3. And I get y is less than or equal to, because I divided by a negative, that sign has to flip around. If you multiply or divide by a negative in an inequality, your arrow has to flip. And that is positive 1/3 x. Negative divided by negative makes positive. Now this is kind of in slope-intercept form, because I can say it's like plus 0. So I get an intercept of 0 and a slope of up 1/3. Dotted or solid?
Solid.
Solid, because it has the equal to bar. And then I need to figure out which side to shade. I cannot test 0, 0 on this because it goes right through 0, 0. So I'm going to test 1, 1. Make any point you want, as long as it doesn't go through there. I like to pick points where I don't have to worry about what's x and what's y. So I like to pick points that are where the x and the y are the same. But it doesn't really matter. Any point as long as the line doesn't go through it. When I plug that in, I get y is less than 1/3, which is not true. So I shade below. Yes?
Do you plug in 1, 1 to the original?
It doesn't matter. You can plug it into the original one, or you can plug it into the one that you solve for y. As long as you've done everything right, they should be equivalent.
Can you go over like what side we use coordinates to test it with? Like I don't understand what.
You can choose any point on either side. So I chose to use the point 1, 1, but anything is fair game. So you could choose the point 6, -6 if you want. You can pick any point. You can pick the point, you can pick something right on the x-axis. So you can pick the point like 3, 0.
And then
plug
if
it
that's,
in.
if that's true, then you should.
If that's true, you shade that point and that side. And if it's false, you want to shade the opposite side. Last one of this type. If this was x equals 2, what kind of a line would it be?
Vertical.
Vertical, crossing the x-axis at 2. It has the equal to bar, so we do a solid line here. And it says x could be equal to 2 or x could be greater than 2, so where is that?
To the
That
right.
To the right. Inequalities are in section 2.6. So if you're like, I think I could maybe use a little bit more practice on those, that's where you would go to find more problems like that. Questions? In 2.7, we learned about piecewise functions. This first one is a special kind of piecewise function called a step function. I can tell because the stuff in the front is just numbers. It's not like a mx plus b, it's just a number. So those are denoting a height then. And what we're going to see is little horizontal segments of those heights. And we know where to make them based on the inequalities. So our x values tell me that between -3 and 0, I want to have a line segment that has a height of 0. So that'd be right on the axis there. Then it tells me that between 0 and 3, I want to have a line segment that has a height of -1. And then between 3 and 6, I want a height of -2. These steps are all very symmetrical. They all have the same length and they're only stepping down by 1 each time, but that does not have to be the case. They can be of different lengths and they can be spaced out differently. So make sure you always check. Don't just start drawing your first steps and then assume a pattern. We're not quite done with this yet because we need to think about endpoints. So in the inequality, we want to look at where we have equal to bars and where we do not. Where we have equal to bars gets closed circles in our graph. And that happens on the left-hand side of each of these. So on the left of each of these, I want a closed circle. And then on the right of each of them, I want an open circle. Questions? Okay. So again, application-wise, I could think of, since I'm a teacher application of this and say, like, let's say you had a project and the teacher told you that you're only allowed to hand it in like up to 3 days early. The teacher just doesn't want to deal with anything coming in before that day for some reason. So if you hand it in up to 3 days early to on time, you're going to get 0 penalty points. But if you hand it in between 0 and 3 days late, you're going to get 1 penalty point. Or if you hand it in between 3 and 6 days late, you're going to get 2 penalty points. So it has some practical applications. Anything where we say this happens for a while and then something else happens can be graphed by a piecewise function. This is also a piecewise function, but this one has some slopes to it, so it's not just going to be stair steps. So the front part is our equations that we would graph like a y equals mx plus b. The back part of the inequalities are where the sudden change happens. So the sudden change on this one happens when x is 0. So the first thing I do is draw a line in my graph there. And say on one side of that line I should see one thing happening, and on the other side of the line I should see something else happening. Then I want to graph my 2 lines. So my first line, I think of y equals mx plus b, has an intercept of 3 and a slope of 1. I'm going to graph out that line. My second line has an intercept of -3 and a slope of 1. But they are not both always true. So this is where I need to look at the inequalities. For the first one, it says that it is happening where x is greater than 0. That arrow points to the right. That means that line should be on the right, which means it should not be on the left. The green one, the second one I did, says that it is true when x is smaller than 0, which points to the left, so it should be there on the left, which means it should not be there on the right. You should have one piece of each of them on each side. Okay, not both on one side. We should see one thing happening on one side and something else happening on the other side. Because these did not come together, we need to worry about their endpoints. If they perfectly meet up, then they don't have an endpoint. But here we have some endpoints. The purple one had an equal to bar, so it's going to need a closed circle. And the green one did not have an equal to bar, so it will need an open circle. Discussion.
Is it supposed to be on the, like the endpoint is on the side that's going away from the center of the graph, or on the main line?
The endpoint should be on that breaking line, because on the other side we should have arrows that's going on forever. Yep, so the endpoint should be on that separation line. Any questions about graphing piecewise functions?
If the equal or greater 2 times is the opposite of what the arrow goes, or is the arrow opposite of what the inequality says?
The arrow should point in the direction the inequality says. So like for the purple one, the inequality is pointing to the right, the arrow should point to the right as well. So whichever way that arrow is pointing in the inequality, the arrow should point in the line, that same line. If you feel like you need more practice on these, they were section 2.7. And then yesterday we learned 2.8, which was also about graphing, but graphing absolute value functions. So we need to think about what the possible changes are that can happen. This one has a change happening outside of the absolute value, which does what to it? Makes it go down. An outside change is going to be an up or down change in the direction it says. So -1 goes down 1. There's no sideways movement in this one. Sideways movement would happen inside of the absolute value. So that means our vertex is just down 1 point. Then we need to plot out a slope. What's the slope of this one? 1 over 1. So the slope should be what's in front of the x. There's nothing there, which means that it's 1 over 1. So up 1 over 1 going to the right. And then going to the left, we want to do the opposite so that it's perfectly symmetrical and mirror imaged. Connect the dots. We get a V shape of an absolute value graph. Questions? Okay, this one does not have any adding outside, but it does have adding inside this time, or really subtracting. What does that -2 do to the graph?
Go to the right.
To the right 2. An inside shift is a sideways shift backwards of what the sign says. So instead of going to -2, we're going to go to the right over to +2. Okay, an outside shift does what it says, up and down. Inside shift goes backwards, side to side. Then from that point, I want to use a slope of 1/4 going to the right, up 1/4. And going to the left, I want to do the opposite, up 1 and back 4. Questions? So that was yesterday in 2.8, if you want any more practice on those. And that's it.